Hello and welcome back. And in this video, we're going to be talking about another linked list interview question. And now this one is related to the last one that we saw. So in the last video, we saw how to find a cycle in the linked list. And this video, we're going to basically determine the length of the cycle. So this is once again another variation of the interview question where you not only need to detect the cycle, but one level up complexity where you need to determine how long the cycle is. So the length of the cycle, how many nodes are involved in the cycle. So the question is, given the linked list, a single linked list, you need to detect if there is a loop in the list. And if there is a loop or cycle in the list, then detect the length of that cycle in the list. Okay. So the example is you have 1, 2, 3, 4, and 4 is pointing back to 2. So you have the length is going to be 2 nodes basically pointing to basically within this loop, right? And so we're gonna actually try to find if there is a cycle and what's the length of the cycle. So take a pause the video here, and basically try to come up with a potential algorithm, and come back to see what we have as a solution for you. All right, so hope that went well. Let's take a look at what we've got. So let's take a look at the visualization first. So the solution is basically going to continue forward from finding the cycle in the list, right? So basically, in the last video, we saw that to find cycle, you actually move your fast and slow pointer, where fast pointer points next element and slow pointer points to the next element until they both meet. That's how you find out that there's a cycle in the list, okay? And then what we do, once we find the cycle, we basically move just the fast pointer to next element, not next, but next element until, and we count basically, and we do that until we come back to the same point where we were before, okay? And the count value gives us the count of the length of the cycle. Okay, so let's take a look at the lab, and that's gonna make things a little bit more clear. So let's go ahead and create our function. Okay, and it's gonna take a list, and it will return true or false. You're gonna print the length, so that's not a problem. Okay, there we go. All right. Detected count. Okay, so first thing, once again, we're gonna once again try to come with the detection first. If there is a loop in the list or cycle in the list. Okay, so we're gonna create our slow pointer and fast pointer, right? Then we're gonna say wow. So slow pointer and fast pointer, and here we're gonna basically do that slow dot next check thing. So slow dot next is not equal to nil, and fast dot next is not equal to nil. Again, fast dot next is not equal to nil. Okay, and now we say slow is equal to slow dot next. Fast is fast dot next. Okay, and we say if slow dot data is equal to fast dot data. That means they're equals. This is where we detected our cycle, right? And now what we need to do is we need to say var count is equal to 0. Okay, 0, right? And we're gonna use another do while loop. So in Swift, do is known as repeat. Okay, and what you do is you say count plus equal 1, and you only increment fast pointer by 1. Okay, and you do this while your slow pointer is slow.data is basically not equal to fast.data. Okay, so this is how, and we're going to print that loop or cycle length is the value of count, and we're going to return true here. Otherwise, we're going to return false. Okay, so we cannot run right now because I need to actually copy this and paste it here. Okay, so there we go. We have counted the length of the cycle. So in this case, we have 1, 2, 3, 4, 5, and now 5 is pointing back to 3. Okay, so we have 3, 4, 5. So in the slide, actually, this should be, this output should be 3. Actually, that's my mistake. There are 3 elements, 1, 2, 3, and 4 that are involved, and we can check that by just ending our cycle here and pointing, yeah, there. So this should still have, oh, no, it's 2. Oh, I'm getting confused here. So you have 1, 2, 3, 4, and sorry, this should point to 2, not 3. So that's where, so 2 is equal to, that's what it was pointing to, right? It was pointing to 1, 2, 3, 4, and 4 was pointing to 2. So node 2, and we say 2 here, right? And instead of 3, 4 points to 2. Okay, so the cycle length should be 3, yes. So cycle length is 3, and there is a cycle. So so this is a mistake. This output should be 3, and we can check, like, it is actually 3. Okay, so with that, as you can see, the time complexity for this one is going to be O of n and m, n times m, or for bigger input, it's going to be n square. So that's the best solution that I could find. Like, you may find like a different solution that's even better. So that's even great. But yeah, like all the algorithm, we can have like, various different solutions. So please, if you find a good solution, post it for the community. And thanks again for watching. I hope you like this video. In the next video, we're going to be continuing forward one step more into this loop detection, and we're going to actually find the head or the start of the loop or the cycle. Okay, so that's going to be the topic for next video, and thanks again for watching. I will see you guys in the next video.